Okay guys, so today we're going to work on an incline problem number 2. This was assigned for homework yesterday. So we have a ramp that has a 30-degree incline, and there's a 5 kilogram box on that ramp. Alright, so let's draw a free body diagram. Okay, so now they tell us this force is parallel to the ramp. Right? Now there's other forces that are in play for this ramp. Okay, so we have gravity, mg, going straight down, and we have the normal force that is perpendicular to the surface. Okay, now in order to find the force of F, we have to break down our components, right? So we have to find what's the components of F. Now, whenever you have an incline problem, it's easier to tilt this and make new axes. Okay, so I'm going to tilt this whole free body diagram. So I'm going to redraw it, and then I'm going to tilt it in the next frame. Okay, so here is my free body diagram, and these are all the forces present. So I have the force of gravity that affects it going straight down, the force that is holding this object straight up, and then the normal force. Now, one thing you should realize is that here is a 90-degree angle. So that's a normal force. If I were to tilt this, where the force of friction would lie flat, normal force would lie straight perpendicular. Force of gravity is going to tilt in this direction here. Okay. Now, how much is that tilt? Well, the tilt that we have, if I tilt this object 30 degrees, it's going to take 30 degrees for it to be flat. So what that means is the force of gravity is going to tilt 30 degrees in this direction. Okay, so let's see how that works. Okay, so if I have the ramp completely as a straight ramp, okay, the normal force is always perpendicular to that. Now, here is my box. Let me draw my box. Okay, so here's my box that weighs that has a mass of 5 kilograms. Okay, normal force is straight up. The force that's pulling it to the right, force Fn, and then gravity. Okay, now gravity in this case is going to tilt in this direction. Now the direction that it tilts, the degrees, this should be 30 degrees. If it's 30 degrees here, for this to go flat, if this line moved 30 degrees in this direction, this line moved 30 degrees in that direction, this line also moved 30 degrees in this direction. Okay, so now that I have that, I can find my components of gravity, the upward components and the downward components. Now, one thing that we should realize is this is held at rest. So that means that this object is in equilibrium. So any forces that are pointing up have to equal the forces pointing down. Any forces that are pointing to the right have to equal the forces pointing to the left. Right? It's the same thing as if you say the sum of all forces in the x equals 0, the sum of all forces in the y equals 0. Okay, so let's look at all the forces that point up, all the forces that point right and left. So in this case, I have two arrows that point up and down. I have the force, the normal, and this component of gravity, the y component of gravity. Okay, so those are the two forces that point up. So Fn has to equal the adjacent side of this triangle. So you see that this is the adjacent side of my triangle, because this is my angle, this would be the opposite. So in order to find the adjacent side of a triangle, we use cosine. Now this, okay, let me just rewrite that in a better fashion. So here is mg. Alright, so the normal force has to equal mg cosine of 30 degrees. Now, what the question is asking to find force F. Now, in order to find force F, you have to take the opposite component of gravity's triangle. Okay, so here's gravity. This is a force of gravity tilted 30 degrees. The opposite component of that has to equal the force that's pulling this to the right. Remember, so any force pulling it to the left, I'll draw a star around here. Any force pulling this to the right has to equal any force pulling this to the left. The only two forces moving left and right in this case is the x component of gravity and the force pulling this to the right. So here we have, to find the opposite component, we use sine. Okay, so mg sine of 30 degrees is equal to your force that's pulling it to the right. Now, mg, m is 5 kilograms. The acceleration due to gravity is 9.8. Sine of 30. When you calculate this out, 24.5 newtons. And that is your force that's holding this object up. Okay, if you guys have any questions, please let me know. If you are out in the hallway, come back into class. All right, thank you. Bye.